Dear students, welcome to Smart Educare video. In this channel or page, I'll try to help you with your science subjects such as physics, chemistry, biology, general science, etc. of both Bengali and English medium. At the current situation, we are in our home since few months, so that our school is off and we cannot learn and practice our subjects, especially science related subjects. So my point is here, I will take class of physics, chemistry, biology or general science or related subjects so that you can understand well and I can help you in an appropriate way. Hope all of you will supporting me by like, subscribe and share or comment in this content. I think time of intro has ended. Let's start today's classes. Today I am going to take a class of SSC Physics. I am assuming that maximum of you has completed the section of SSC Physics about motion and force. Of course, at least 3 months you had your classes. So I am here starting physics from 4th chapter. Hope you already know it is. Yes, it is work. Actually, the full name is work, energy and power. So in this chapter, we will know basic definition, explanation and application about work, energy and power. Of course, you are in a basic section of science. You can call it the ABC of science, but we cannot discuss everything about it. In a certain period or in a certain system or in the level, we can discuss everything. So for the first class, today's lesson about work. So let's begin. In a daily life, we can do anything. Okay, in daily life we can do anything and all of us can call it as a work. But in physics, definition and explanation of work is quite different actually. How can you say a work is? Normally, what we can do, we can call it work. If we are standing here or if I am speaking here, you cannot see me, so if I am speaking here, so it is work. But in physics, I cannot say it, or scientifically it cannot be said that I am working. So why? So let's try to find out. First of all, you have to know the definition of work. So I am writing it in the board. Please write down on the notebook of yours. So first of all, I am writing the name of our chapter, which actually for the lesson. So what we will know about work today? We will know about the definition of work. We will know the explanation of work. We will know the application of work. Without application, science is nothing. So, first of all, the definition. What will be the definition? Definition, we can call it, the work is a measurement of energy. Work is a measurement of energy transfer that occurs when object transfer that occurs when a is moved over a displacement, is moved over a displacement. Or you can say the distance. Actually, displacement is a lot of quite a hard word to say. So I think distance is a better word to understand actually. Of course for writing displacement is better, but for understanding distance is better, so I am writing the both ones. By an external force. At least a part. So here is the definition of work. Okay, I hope you are writing on your notebook. So we got the definition of work, right? Now we can go to the explanation of work. Now, first of all, already you have completed 3 chapters of physics actually in science, so you know what do you mean by explanation in science. In explanation, you need to know something works or some things can be applied by a formula, either it is scientific or theoretically, it doesn't matter, but you have to complete it with a certain formula that some scientists or you can say a specialist can provide, it can be proved, right? We are now trying to explain the work. We got the definition. Now I am going to tell you the explanation of work. Explanation means how how work works or works can be measured and the mathematical expression of it. So first of all, I am telling you what you know the scalar quantity and vector quantity, and of course work is not a vector quantity, work is a scalar quantity. If the question in your mind that why work is a scalar quantity, then I can say to the answer, because a scalar quantity, the product of a scalar quantity and a vector quantity is always a scalar quantity, right? Okay, so after a few minutes you will see that how I got it or how I am telling it. So first of all we can say it, work is a measurement of energy, right? Work is a measurement of energy transfer that occurs when an object is moved over a distance by an external force. Just follow these words, external force. Without external force or without applying external force, no work can be done. That's why if I am speaking right over here and you are listening right over there, but you are not doing any work because you are not applying force or not moving anything, right? So 2 things are important in here. One is applying force and the second one is moving objects. So first of all, basically now we know that the basic in physics and basic in daily life works is quite different. Now I think the time that we can know it mathematically. So mathematically the work is indicated by the W, work, just normal formality, this. Work, first one is W, so work can be indicated by W. So work, already I have told you that work is a measurement, right? So if work is a measurement, then we can measure the W but how? By multiplying of force and displacement. But of course it is a normal product of force and displacement, because think about it. First of all, for work you cannot indicate in a direction. There is no indicating direction in work. I'm working, it doesn't matter in which direction I'm working. Just think about that. First of just suppose point A and point B. Someone is carrying 5 kg goods to point A to point B. So here is the displacement is A to B, and also this C. If the A to C and A to B, if AB equals AC, that means the distance or displacement of AB and the distance or displacement of AC is the same, then 5 kg can be carried to either B or either C, but the work will be the same. So the direction is not controlling the work. That's why work is a scalar quantity. Of course work is not a vector quantity. Just remember that. So now we know the formula, but actual formula I am writing it. Actual formula is F S cos theta. Why? Just think about it. In this example, I am talking about a straightaway work. But if you think kicking a football or tennis ball or hitting a ball by a bat, then of course there is a curved way, not a straightaway, right? These motions are always to be curved, not straight. So in this section we can call it a curved way or not a straight line. For not a straight line job or a curved work, what we can achieve if F and S, because we don't have any S. Suppose here is a ball and you are just kicking this one. If ball goes under this one in such a way, how can we measure the displacement like this? If it is T, then if the displacement is this, it is not the correct one, right? Because it has all around this way. It goes all around this way. So how can we measure this displacement to directly to P? So it is not possible. For this, we need the applying force and the direction, and between them an angle is working. So this angle we are calling it theta. In physics we are calling it theta, and this theta is working here for measuring the works. So just look out there that Fs cos theta. Why it is cos theta? Because it is towards the force. If it is looks like on this direction, then we would have written here sin theta. But it's a long story, but not for your level. That's why I am not discussing this on this lesson. Okay, then we can go on the further thing. Further thing means we know the W equals Fs and the Fs cos theta. So we got the two formulas. One is Fs and other is Fs cos theta. And of course the Fs cos theta is the main one. From Fs cos theta we got the Fs. How? I am showing you now. Just suppose this ball is in the same position, not the position I have already drawn. If it is not, if it is just passed, just think about it. If it is just passed from A to B, so force F is applied A to B, and displacement has also A to B. So the angle, or that means the angle theta between F and S is what? 0 degree. Why 0 degree? Because the direction of force and displacement are the same. So here the angle is 0 degree, just this 0 apply here. By applying here this 0, we can find this one. How? Fs cos 0 degree. If we have already you have been discussed trigonometry, I think so, but if you don't, then I can tell you that the mean of cos 0 degree equals 1. So if it is 1, then Fs into 1 equals the product of Fs and 1 equals Fs. So just think about it. First of all, I have shown you W equals Fs. Then I show you a different way, W equal to Fs cos theta. Now I am proving it from Fs cos theta to Fs. So everything is in the same way or in the same direction. Not the direction in physics I am of course talking about. I am talking about the theory. First of all, we know the theory, then we can explain or we can apply. But in a basic theory, you have to know everything in your certain level. So I think the mathematical expression of work is done here. What do you think? Let me know. Just leave a comment, then I will try to reply. Then I can tell you about the unit and dimension. You know how to measure unit and dimension. If we can mathematically prove the dimension and unit, maybe it will be better to understand, I think. So let's try to find out that what is the unit and dimension of work you can find by mathematics. Just already I have told you that W equals normally W equals Fs. W equal to Fs means we know F equals mg or ma. Normally we can say it ma for falling object or free falling object, we can say it mg. So ma is, so just put the unit on those substitutes. M, that means what? Mass, that means kg. A, that means meter per second square, and S, that means second. Second, is it? No, it is meter. So we can call it right, of course, right, but unfortunately we are not calling this one as a unit. So all these things are called in a constant, we are calling it joule. It is indicating by J. Okay, all is indicating by J. Of course it is an SI unit. You know about SI unit, CGS unit, MKS unit, different kinds of unit are over there. But in a present way, or international unit, we are using SI unit in all the aspects, especially in science. If there is any question have the different units in one question, then you have to convert all the units to SI units for your better result or accurate results. So I think you will you understand what I have said. If you don't understand, leave me a comment, then I will try to reply. Okay. So this one is the unit, right? On now let's go to the dimension. You know what the dimension is? So same here. W equals F S. So what is the dimension of F? Let's break it out. F means M A. I've already written it. S means displacement, right? S. M is what? Of course M. L is A is L T square. S is L, right? That means M L square to the power minus 2. This one is the dimension. That means how we can write it? Right, like this. So here's the unit and dimension of work I've written. I think you understand. If you don't understand, please leave me a comment, then I will try to reply. Of course, already we know the definition, and also we have whatever I can say. read or discussed? Yes, discussed. Of course, we have discussed the explanation of work. We know the unit of work. We know the dimension of work. Now we can go some application. What do you think? So try to go on some application. Okay. So we got the definition and the explanation. Let's start about an application. Application means what? Application means in your theoretical system. In your theoretical system, that means in your question answer paper, by your question you have to answer something, answer some problems, solve some problems. By solving problems, you can get marks. For solving problems, you need formulas, right? And those formulas we can get from our basic discussion. So, my first question, it is I think it is in an NCTB book. All those are in NCTB SSC Physics for class 9 and 10. It doesn't matter, both are the same book. So, first I am writing the question. So, it is problem, right? So, I am writing it as a problem because we haven't solved it yet. So, it is a problem quite to me and also to you, I think. So the problem is your mass is 50 kg. I don't know what is all of your real mass. Your mass is 50 kg. You have climbed up a 10-story building. Building. How much work have you done? So there's a point in your book that height of each floor is 3 meters. So let's try to solve this problem, right? So think about it. Of course, there is a work has been done here because someone has the mass of 50 kg and he climbed up. That means he has moved. So something has moved or an object has been moved. So there's a work. Of course, there's a work has been done, but how much we have to calculate. So for this, I am telling you about just. Be with my way. I don't know in your book. Actually, different ways can be done. Every mathematical problem, different ways can be done. But I am giving actually a short augmented. I can say it. Short arranged. I can say it is a better word. Short arranged. So here or given whatever m, that means the mass. The mass what I have mentioned about. 50 kg, right? So your mass, that means a person's mass, and he is stored a building. So just think about that. If he is climbing, that means he is applying force is indicating or the direction of his applying force is directly below actually the center of the earth, right? That means by him applying force is about his weight, right? From class 8 we know that W equals mg. This formula can be used here. W equals mg. That means his applying force is W equals mg. So we need g. So we know the mean of g equals 9.8 meter per second square. I think all of you know it because we are reading science here already. We have taken so much knowledge on science in class 6, 7 and 8th grade. And so I am thinking you are okay with this. Then the displacement. S is the displacement, I have already discussed it and we have already read it on your book on the motion and force chapter. So in the S, just think about it. There is a 10-story building and each floor is 3 meters. So we have to multiply those for calculating real height, right? One floor height is 3 meter, then 10 floor height equals 10 into 3. That means the total displacement equals 10 into 3, that means 30 meter. Also, we have not work and we need to calculate it. So we know W equal to Fs, but here is nothing about F, but we know that F equals mg, right? I have already told you that if he is climbing, that means he is applying force, that means it is weight, and we know the weight is mg. In S we can write the same one. So what is m? 50. What is g? 9.8. What is s? 30. Just multiply it and we can get the 14,700 joule. Joule means, already I told you, joule is the unit of work. Also we can break it. We are really breaking it. We are writing by breaking it. 14.7 into 1000 joule. That means we can say 14.7 kilojoule. You know the kilometer, 1000 meter equals 1 kilometer. Like that, 1000 joule equals 1 kilojoule. If you write this one, that will be also correct. Also, you can be more smarter from other students in your answer paper by following this system. Also, this is a normal problem, and it is in your NCTB book. You will find there. But some cases missing here. How? Because we know the formula of work is two different ways. One is a straight way and other is a curved way. Actually, curved, what we can curve means there is an angle between force and displacement, right? Now just think about someone climbed up a 10-story building, but not climbed up a 10-story building directly. He is climbed up a 10-story building by stairs. Just think about it. If someone is climbing up a 10-story building by using stairs, and every stair is 30 meter angled, what you can say, the angle between stair and the floor is 30 degree. What is the unit of angle? You know that? Degree, right? So 10-story building, how much work have you done? So there is a simple connection. You have climbed up a 10-story building using stairs. How much work have you done? Height of each floor, it is okay, but we need the angle. And already I am telling you, actually I have told you that the displacement and the force, the angle between them is 30 degrees. If, just think about it, if the angle between force and displacement is 30 degrees, then what will be the result? Is it the same way? Let's find out. We can calculate, then we can tell it that it will be the same or not. I think I need to change the question. Actually, not changing it, upgrading it. So I have upgraded the problems. Actually, I have a previous question has not any angle, but this one has an angle. Try to write this in notebook, and I'm telling it. I think you will pause the video, then you can write notebook later, no problem. So if your mass is 50 kg and you are climbing up a 10 meter height by using stair, just think about it. It is now stair, not climbing up directly. If it was climbing up directly, then there is no stairs, there is no angle, and there is no such way to measure the force in a curved way. I already told you there is a straight way and there is a curved way. In the straight way, directly we can use W equals Fs, and in a curved way we cannot use the Fs, we have to use W equal to Fs cos theta. For this one, we need a different actually measurement of theta, and already I have written here that the angle between stair, and floor is 30 degree, right? So just a whole same as here, m equals 50 kg is equal 9.8 meter per second, theta equals 30, you know the theta, the angle between stair and floor is 30 degree. Not just a stair and floor. In a previous, I have already mentioned the kicking football theory. In the kicking football theory, I have already mentioned it is a theta, right? I think you can go backward there and you can check it yourself, no problem. So theta equals 30 degree, s equals 10 meter, and w equals what? You know, there is a w. What w is what? The work. We need the work. So now